Hi, today we're going to talk about more properties of continuous density functions, such as the one given above by f of x, k times x squared, and where x is between 0 and 1. Here there's an infinite range or interval of possible numbers for x. So it is indeed continuous. We're asked to calculate the value of k that makes f of x a valid density function. So if we answer the first question, we should remember total probability is 1. And this is the integral from minus infinity to infinity of f of x dx. But remember, the function is only non-zero on the interval from 0 to 1, so we just integrate from 0 to 1. This will be k over 3 times x cubed, evaluated at 0 and 1. And when we do the evaluation, we're just going to get k over 3. So k over 3 must be equal to 1. That tells us k is equal to 3. And that is one part to ensuring we have a valid density function. So that was part A, not to be confused with A1. Part B, the second requirement, is that f of x, well, that's equal to 3x squared, 0x less than 1, and it's 0 for all other values. This is bigger than or equal to 0, and that is the second requirement to be a valid density functions. So f of x is a valid density function, and we found the value of k that makes it work. Our second question here, A2, is to calculate the probability x is less than 1/2. This is equal to the integral from 0 to 1/2, so that limit goes right there. We could have put minus infinity, but the density function is only non-zero from 0 onward, from 0 to 1. Okay, so those are our bounds. And we need to integrate 3x squared dx. This is equal to x cubed, 0, 1/2. I think we're going to get 1/2 cubed minus 0, a 1/8 chance that x lies there. Now, for the third question, we're asked to calculate the mean. And that is just the expected value of x. That's the integral where it's non-zero, so 0 to 1, of x times the density function 3x squared. Okay, so we need to integrate from 0 to 1, 3x cubed dx. That'll be 3/4 x to the 4th, evaluated at 0 and 1. That'll just be 3/4 minus 0, so our answer is 3/4 for the mean. Now finally we're asked for the variance of x. The variance of x is e of x squared minus the mean squared. We've already calculated the mean. That's 3/4. That's squared. The only thing that's left to do is calculate e of x squared. Well, we integrate x squared times f of x from 0 to 1, and we're going to get integral from 0 to 1, 3x to the 4th dx. This will be 3/5 times x to the 5th, evaluated at 0 and 1, so 3/5 minus 0. In the second moment, e of x squared is 3/5 minus 3/4 squared. And this is the variance. Okay. So just a few examples of using some definitions to calculate value of k that makes a valid density function, to calculate probability, to calculate expected values, to calculate variance. Thank you very much.